Okay, so I can see that most of the learners who have joined with us today are completely beginners to the deep learning. That's perfectly fine because I'll take you through the basics itself. So you don't have to worry, and I'll be ensuring that everyone, irrespective of your knowledge skill set from the deep learning perspective, you'll be able to follow along with me if you are with me in this overall session. Okay, so I see most of the learners have joined in. So, okay, let me start with the introduction again. So, thank you so much, everyone, for joining in for this deep learning session with Manifold AI Learning. My name is Nachiket Murthy, and I'll be your instructor in this session. So, let's understand with the definition of what exactly is this deep learning and why do we call it as deep. That's a important term that we have to understand. See, when I say deep learning, so if I want to describe from the perspective of the overall machine learning, okay, so in the case of this machine learning, see, machine learning is a kind of a system, okay, it's a kind of a system which we can, it's a kind of a system where using the system, we can learn the patterns in the data set without explicitly programming. To give you an example, okay, let's talk about the general developer side. See, from the developer standpoint, what do we do whenever we are given with the problem statement? So whenever we are given with the problem statement, we would go ahead and observe the data set, and we are going to write the logic as a developer. Now once we write the logic, so whenever a new data comes in, this logic will be utilized and we are going to get the output. This is what happens in the traditional software. Now in the case of the machine learning, it's slightly different. So as we have learned in the last session, but let me just give you for the other learners as well, for the benefit of others. So in the case of machine learning, what happens is you as a individual, when you're working with this machine learning algorithm, you will provide the data. Along with that, the expected output. You'll provide this to a machine learning algorithm. Now, the best part is this machine learning algorithm will provide you the logic. That means whatever the effort that you are putting in to come up with the logic, you no longer have to do that. The machine learning algorithm will establish that relationship between the given data set, and you can just use that learned pattern and generate the prediction. That's the best idea, and that's the amazing part about this machine learning. Okay, so that's the amazing part, guys. So here, when we talk about this machine learning, see, you've got the data, expected output, and that would result in the logic, like that will give us the logic. Now, one of the challenge in the machine learning is, so as and when the data increases, the number of features increases. So at that time, the challenge is going to increase. The machine learning performance is going to decrease. And in some scenarios, the machine learning model will not be able to capture the complex pattern in the data set. Now think about it. We have said that the machine learning can learn from the data. Now whenever we start feeding new data, it is not able to learn the pattern. Now that's where the deep learning came into picture. So this deep learning, it's a special kind of algorithms. So what we are going to do is we'll make use of a structure, we'll call it as the neurons. We make use of such neuron in order to find such complex patterns in the data set. To give you a visualization, so let me just take you through the TensorFlow page. Okay, I'll say TensorFlow playground. Let's go to the TensorFlow playground. So I'll take a famous scenario. Okay, this is a scenario where you can clearly observe that we have got the data. So we have the data which is in the form of concentric circles. Now this is a data which represents the nonlinear pattern in the given data set. Now when you have nonlinear pattern in the data set, if you try to use a simple models, let's assume that I'm going to make use of a simple model. Let's say the linear regression, logistic regression algorithm. So I'm making use of sigmoid activation, which says that we are going to apply the logistic regression since I'm using a single neuron. So if I try to make use of this logistic regression algorithm and try to find the pattern in this complex data set, see, can you observe? I'm unable to find the pattern in the data set. I mean, it has drawn the decision boundary to describe between two classes. So this is the decision boundary it is showing, but clearly it is not doing a good job. So we still see a lot of misclassification that is happening in this given data set. That means we need a better way to find the patterns in the data set. Now, in case of machine learning, what you would generally do, you would go ahead and choose maybe a powerful algorithm. Maybe you will choose the random forest, or you will choose the bagging algorithms, other bagging algorithm, or a boosting algorithm, depending on the use case. So that means you have to manually try out the various algorithms. Now, here, what we can do is, okay, in this scenario of deep learning, since we are going to make use of neurons, we can increase the complexity of the network. Now let me demonstrate it. Instead of one neuron, this time I'll choose three neurons. And if I do the training, you'll be able to observe that, see, after a few epochs, we are able to learn the pattern in the given data set. So this clearly shows if we have a sufficient number of neurons in our neural network, we are able to learn the pattern. So that's the power of deep learning. Now, while explaining that, I've made use of a lot of technical terms. So let me just break down one by one to help you understand what is happening right here. Now, this overall structure that you see right here, we call it as a neural network. Now, in this neural network, as the name clearly says, it is made up of neurons. And in this neural network, we'll have input layer, we will have a hidden layer, and we will have an output layer. So these are the three layers that you would have when you're working inside this neural network. Now, input layer, as the name suggests, we are going to use this input layer to send the input. Uh, we'll be using this input layer. And then this input data will be processed and sent to the hidden layer. And the data, sorry, we'll not be processing in the input layer. We'll just send the input through this input layer. And then we will process this input in the hidden layer. And then this process input flows to the output layer where we are going to display the output. That's the basic idea about this neural network. Now, in this scenario, I've got one hidden layer. So if I want, I can have multiple hidden layers too. Like this time, this is an example of two hidden layers. In one hidden layer, I've got three neurons. In the other hidden layer, I've got two neurons. Okay, input layer, hidden layer, and the output layer. These are the core parts of this neural network. Now, whenever we are processing the data, okay, the data flows from left to right. That means the data flows from input layer to the output layer. The data moves forward. Now, when the data moves forward, when we find the output of the neural network, we call it as the forward pass or a forward propagation, where I would go ahead and process the input from my input layer through the output layer. That's called as the forward propagation. Now, when the data is being processed inside each and every neuron, see, I've got one hidden layer and I've got three neurons, right? Now, the question is how the data is being processed over here. Well, inside each neuron, we'll perform two steps. One will perform the linear summation. The other one, we call it as the activation. So linear summation is nothing but taking the dot product between your weights and the input. And the activation function is a mathematical function which we use it to transform the output from the neuron to a required range. So those are the two steps that will be happening inside each and every neuron. Okay, so in each and every neuron, we'll perform this linear summation and activation, and it is being done in each and every neuron. And at the end, we'll have the output from this neural network. That's the core concept of this neural network. Now that you have a basic idea about it, let me just take you through the hands-on in the TensorFlow library that would help you to grasp all these concepts, and you'll be able to visualize what is happening over here. That will make your life much simpler when you're learning this deep learning. Let me take you through the notebook. I'll start a Google Colab session. And over here, I'll start by importing the necessary libraries. So in order to construct the neural network, so we have various libraries, guys, and two of the famous one I would say are PyTorch and TensorFlow. In our session, we'll be just making use of this TensorFlow library. Okay, so that's what I'll be doing it. Now, if you are preferring to use it PyTorch, you can also go ahead and use that PyTorch as well. So let's start by understanding as how to work with this TensorFlow library. Just like we import any Python library, we'll start by importing the TensorFlow library by making use of the alias name of TF. Okay, import TensorFlow as TF. And then I'll also import, let's say, NumPy, Matplotlib, and other libraries. And apart from that, maybe I'll also go ahead and import some required object. I'm going to say from TensorFlow dot keras dot layers. I'm going to import dense from TensorFlow dot keras. I'm going to import, okay, I'm going to import sequential. Okay, this is what we would have in this TensorFlow library. All right, so will start by doing the necessary imports. So don't worry about what is happening right here. So here, I'm just using the layer and then object. We'll talk about it as and when we write the coding, guys. Okay. And I see a question from Navi Kaya, generative AI course bundle increased. Okay, so just a second, folks. Navi has a question about the generative AI. Okay, sure, Navi, let me answer that. See, I think that's correct. So there has been a price increase on the generative AI. So they have introduced two different plan. One is 2 years plan and the lifetime plan. So I think if you're since you're an existing learner of our community, I think you might have received an email as well. Even I got to know from the leadership team of Manifold AI Learning. So if any learner is uh, like I can say is extending, I would say, let me just answer it in this way. So if any learner is buying the 2 year plan, they'll be getting the free upgrade for lifetime plan. So it's valid for only, I think, 24 hours. That's what I got to know from the leadership team of Manifold AI Learning, Navi. So you can reach out to the support team. But as I mentioned, I think this offer is valid for 24 hours. You can check with them. You can get yourself upgraded if you're looking for it. One is lifetime plan and the 2 year plan. Okay, yeah, let's come back to our learning, guys. So if any other questions is there, guys, yeah, feel free to let me know. If it is not relevant to our class, I'll definitely take it up at the end of the session. So we'll focus on our learning first. So here I'm importing the sequential object as well as I'm importing the dense. So we'll talk about it, how it works. Okay. So first thing is we are understanding as how to build this kind of neural network. So to make it simple, we'll be considering our network in this format. So what we will do is we would go ahead and create our network in this manner. Okay. So here we'll have two inputs and a single neuron. Okay. And this single neuron will be processing the two inputs, and this is going to generate the output. So that's how we will be going ahead and like we'll be constructing this overall neural network. All right, guys. So what we are going to do is, so here in this case, we'll try to understand, okay, how the data is getting processed inside this neural network. So in order to create the neural network inside this TensorFlow library, first thing that we are going to do is we are going to create the object, which is a sequential object. So I'm going to say model is equal to sequential. Okay, so I'm going to create the model as sequential. What it means is the model object is made up of multiple layers. That is what it means by creation of sequential object. We would go ahead and create the sequential object. And with this sequential object, so we'll be able to add multiple layers which are stacked one next to the each other. That's the overall idea about this sequential object. Now for this sequential object, if I want to add a layer, I'm going to say model.add. Okay. And after we specify the add, we have to mention the type of layer that we want to add. Here, the type of layer that I want to add right now is the dense layer. Okay. The type of layer that I want to add right now is the dense layer. Now, what is dense layer? Dense layer is a special type of layer where I have the connection starting from my input layer to every other neuron in the next layer. That means here in this scenario, if you observe, okay, this neuron is receiving the input from every other neurons in the input layer. So if I have those kind of connection, we call it as a dense connection. So we will say this as a dense connection. And for this dense connection, how many number of neurons that we have in this layer? We have one. So I'm going to say units is equal to one. Then I'm going to mention the first, I'll mention the activation as linear. Okay. When I say activation as none, to say that there is no activation that I'm using. Okay. Now for the demonstration purpose, what I'm going to do is I'm going to send in two inputs. That means just like this receives two features, right? I'm going to send in two features. This is how I'll be creating the model. Okay. So what we have just done is we have created the model. Okay. I think I missed this tense. Now it should be okay. Yeah. So now if you look at it, this is how the model would look like. Now let's try to get the visualization of it. If I try to visualize this model, tf.keras.utils dot plot underscore model. Okay, this will help us to visualize the model. Let's do one more thing. Let's also mention show shapes and all those things so that we can go ahead and visualize it. Okay, we'll say show shapes as true. This will help us to get a better idea as what is happening. So it says that I have an input layer and this input layer has got two features and these two features are being sent to a single neuron of this dense layer. That's what it says right here. Now let's get a dummy data. Okay, let's get a dummy data and let's apply a dummy data on this model. So let's try to do that. So in order to do that, I'm going to say x is equal to np.random.randint. So I'm going to generate an array. Maybe I'll have 5 rows and 2 columns. Okay, and I'm going to convert it into the uh, floating point. The reason is if I want to apply it on my neural network, I'll have to have my input in the floating point format. So this is how my x would look like. I've got the x, I've got each row, and each row is having two features. That is how our data set would look like. So this is how our data set would look like. Now with this data set, guys, okay, now with this data set, let's go ahead and apply it on our model. So if I want to apply it on the model, if I say model X, I'll get some output over here from this model. So the model, the output is minus 80.25, minus 60.03, minus 82, minus 49, minus 58. So this is the output that we are getting from the model. Now let's try to understand how are we getting this output. So let's refresh back and let's have a quick recap as what I have mentioned. So what is happening inside my neural network? Inside each and every neuron, we perform two things. One is linear summation, and this is followed by activation. Now, in our case, the activation is set as none. So what is linear summation? It is the dot product between weights and the inputs. So this is basically known as the linear summation. So let's try to understand this dot product between this weights and the input. See, we have the input 89, 37, 66, 88, and so on. So what are these weights? How can we get these weights? So if we look into our model, we have got a layer. This is the first layer that I've got, which is only layer that I've got, and it has got a single neuron. We can actually get those individual layer weights. So let's look into the same. If I want to get the layer weights, so model dot layers, I'm going to access the first layer. And from this first layer, I'm going to call get underscore weights. This will return me the weights which are associated for each input. It says minus 0.86 and minus 0.94. Let's just save the same. I'm going to say W1 is minus 0.86. W2 is equal to minus 0.094. Okay, this is how our data would look like. And we also have the bias sum, which is 0. So we also have bias. This is equal to 0, which is this value that you see right here. Okay. Now the dot product between the weight and the inputs. Dot product is nothing but taking the dot product between this vector and our matrix that we have got. Okay, so let me just create a vector in this manner. I'll just say w is equal to nb dot array w1 w2. Let's look into the shape. Okay, what is the overall shape? We have got the shape as 2 comma 1. So this is the weights, that is minus 0.862 and minus 0.094. So what we are saying is we'll take the dot product between the weights and the input. So I'll say x dot w. I'm getting the output as minus minus 80.196, minus 59.992. And if you look into the above output, see, we are getting the same output. So what it proves is that the first step inside every neuron is basically taking the dot product between our input data and the weight matrix vectors. Okay, that is a weight vectors. So that's the idea of this. That's the idea of this first operation inside each and every neuron that's working with this like single neuron, that is our neural network. Okay, so we have understood what exactly is this linear summation. So what you have seen just now is how a data is getting processed inside an individual neuron. So guys, is it clear so far? So I'm sharing you the code link in the chat window. Please have a look into the same. Click on that link and you'll be able to access this notebook link and just go through this code, execute it at your end. You might be getting different value. That is completely fine. So just ensure that in place of W1 and W2, you mention the values that you're getting it when you're executing at your end. So if you're clear with whatever I've taught you so far, please confirm by typing in as all good. If you've got any question, let me know. I'll give you 2 minutes to review the code. In the meantime, now, if you have got any questions, please free to let me know, team. Okay, in the meantime, Navi, I got a confirmation from the management of Manifold AI Learning. Yes, I think the bundle course has been increased. But yeah, the learners who are purchasing the two years plan, they'll be upgraded to lifetime plan for free, Navi. So that's the confirmation that I've got, and that's valid for only 24 hours. If you have got any specific question, if you're there on call, you can let me know in the chat window. I think the team can answer any of the queries that you might have. So team, once you have gone through the code, please confirm by typing in as all good. Okay, thank you, Darshan. Thank you, Samiksha. Thank you, Dheeraj. Thank you, Lakshman. How about others? Is it clear? Thank you, Rakshit. Okay, that's great, Akshay. Okay, I'm glad, Mahesh, that you're able to follow along. Okay, thank you so much, guys, for confirming. So, what we have learned is to inside a neural network. Okay, a neural network is basically made up of multiple neurons, and inside each neuron, two things would take place: linear summation and activation. And you have learned about the linear summation. Okay, in the case of this linear summation, so it's basically taking a dot product between our like input data and the like it's taking a dot product between our input data and the weights. Okay, that's what is the linear summation is. And this is followed by activation. Now, activation is basically a mathematical function. There are various activation functions that is supported by the TensorFlow library. So some of the common ones are ReLU, TANH, sigmoid, and linear. Linear is nothing but no activation. Okay. So when I say sigmoid, it's basically application of this sigmoid activation function. So what is sigmoid activation function? I'll say I would mention I'll just create a custom function and then I'll apply the same. Okay. Def sigmoid 1 over 1 plus e power minus x. So it's going to return me the output from this sigmoid activation function. So what I'm going to do right now will bring up our data model again. And this time I'm going to mention my activation as sigmoid. We'll do the same activity. Okay. There's no changes. Okay. We'll do the same activity, but this time with the activation of sigmoid. That's all. So first I have applied it. Now I'll just say model X. Okay. When I say model X, this would go ahead and give me the output as 4.44 into 10 power minus 28. And this is how the overall output look like. Okay. Which is all the values are actually closer to zero. Let me do one thing. Let me just initialize it again and let's see. Okay. Now all the values are zero itself. Let's see if we can get some value which is better than zero, so that it is easier for you to follow. Okay, let's do one thing. I'll just use the ReLU activation function. So instead of using the sigmoid, yeah, this makes much simpler. And I'm going to write a function for ReLU as well. So in case of ReLU, what this is going to do is it will return the maximum of 0 comma x. That's what it is going to do. Okay, so when I apply the forward pass on my given data set, so I'm getting the output as 0, 26.96, and 6.93 and 0. This is how the output from this model would look like. If I go ahead and apply it in the same way, so let's go ahead and get the weights. So I would go ahead and get the weights in this manner. So this will help me to return the values of weights. Okay, this is the set of weights that I've got. Okay, now we'll take a dot product between these weights and the input that we have got. So I'm going to say x dot w. Instead of that x dot w, I'll just mention this entire expression. See, if you look at it, I've got the output from this forward pass, like a linear summation. So I'm going to call it as z. So the output from this linear summation is this 38.690, minus 20, 26, 6.93, and minus 12. Now I'm going to say ReLU and I'll apply this Z and you'll be able to see the output. See, I've got the output as 38.690, 0, 26.96, 6.93, and 0. That means whatever the output that we had earlier, okay, whatever the output that we had earlier, we have the same output here as well. So this brings us to the conclusion that whenever we send the data to a neuron in our neural network, two things would take place. One is forward pass or the forward propagation, where we will take a linear summation of the given input, and then which is then followed by the activation. So this is what would happen whenever we apply the data to a single neuron, or even if you consider the deep learning neural network. So that is the core idea behind this, working with this deep learning neural network, guys. Okay, so I'll take a pause here. So any questions so far, guys? Let me share you the link again. So you can just use the same link, or you can also use this updated link too. So do to check out the link. So you should be able to access the link now. So we have created the network and we went ahead and created the neural network in this panel. So go ahead and check out the code that you have got and let me know if you have got any questions. So I'll give you a minute, just have a quick review on the code. If you've got any questions, let me know. If you're clear, so confirm by typing in as all good in the chat window. So we'll proceed ahead. I've got an interesting thing to show you. Okay. Uh, Amira says that can I access the package? Oh, yes, Amira. Yeah, you can also go ahead and access it right away. So as I mentioned, you have to reach out to the support team once you have made that purchase. Okay, in if that's the question that you have got for the lifetime access. All right, and here, uh, let's come back here. So I see confirmations from most of you. Sagar says, sir, no question. Lakshmikant says, no question. Sangeeta says, no question. Excellent, guys. Thank you for confirming and thank you for your participation and thank you so much, guys, for being so enthusiastic and asking some of the amazing questions. So I see the learners joining from various sources from our live streaming, from our YouTube channel, and our LinkedIn and multiple places. I see questions are pouring in. So thank you so much, guys, and feel free to let me know your suggestion as we proceed so that I can deliver you a best learning experience. Okay, now that I see the confirmations from most of you, so let's proceed ahead and let's look into this scenario that we have got. Okay, so here in this scenario, we are now talking about the TensorFlow library. Now, this resource of uh, the TensorFlow library and this overall slide, it's also part of the manifold AI learning workshops which I've talked about. Okay, if you just go to the page, let me just show you again. If you click on courses, if you just hover to the workshops, okay, over here you can access the introducing TensorFlow. That's the slide that I'm currently using right now. Okay, this has got the overall content for you to learn, and it has got some good content over here in this slide. I would request you to refer to it in case if you're getting started with TensorFlow. Now here we've talked about this TensorFlow and we've already seen how to work with the same. But if I want to provide more information, it's an end-to-end machine learning platform which has got a comprehensive, flexible ecosystem of tools as well as the community resources that will let the researchers and the developers to build the state-of-the-art machine learning models and deploy the machine learning powered applications. So these are some of the advantages of TensorFlow. And here, like to give you an example, it has got the functionality called AutoGrad, which is nothing but the automatic differentiation or automatic gradient computing. And it provides scalability. We can create the pipeline and perform complex operation. It provides the Tensor board, which is another component of TensorFlow library for better visualization of training. And it's backed by Google, so you will get the recent updates, and it will ensure that we are able to implement it not just for academic purpose but also for production. So that's the advantage of learning and working with this TensorFlow library. Now to get started, we'll have to install it. So since we are using Google Colab, the Google Colab comes with pre-installed. We don't have to do the separate installation. And here, in order to build a neural network using TensorFlow, we'll start by importing. This we have seen already, and we'll start by creating the model as sequential. Then we can add the individual layers. Okay, so we have seen in detail already how we can build it from scratch in the first part of a learning session today. And when we are working, so there are various activation functions we can specify. We have got sigmoid, we've got softmax, tanh, relu. So these are all the various activation functions that we have got when we are constructing the neural network. Okay. Now, apart from that, we can also go ahead and like once we go ahead and construct the neural network and specify the neurons, we can then go ahead and perform the activity of compile. Okay. In the step of compile, we will mention the optimizer, we would mention the loss function, and we'll also mention the metrics. So these three components will help the neural network to get trained and find the values of weights and bias sum in a much efficient way. So that's the role of this model.compile. Then here in this model.compile, we'll have to mention three things. One is optimizer. Optimizer is nothing but the learning algorithm. What is the strategy that this neural network has to follow in order to update the values of weights and bias sum, the value of loss function, like what is the loss function that is suitable for the given task, and the metrics, like how exactly we have to evaluate our model when the training is happening. So these three things that we have to mention in the compile step. And once we mention these three details, we would then go ahead and perform the fit. So while performing the fit, we'll say model.fit, extrain wide range, we'll specify the batch size, followed by number of epochs. Okay, and we'll also specify the validation data. So this is how we would perform the activity of training of our deep learning model. Now here, I just want to add one more important thing, guys. I'm going to take you through the slide, and I want you to observe this slide very carefully. So this is what you would be utilizing whenever you are constructing the neural network. I want you to just make a note of it. If you're getting started in deep learning, you can just make a short notes or a sticky notes from these slides and keep it with you. That would come in handy. So whenever you're working with deep learning, so you would basically work with three types of tasks. One is binary classification, multi-class classification, and the regression. So these are the three kinds of common tasks that you would deal with while working with deep learning neural network. So here you'll have the inputs. The number of inputs is nothing but it is one per input feature. Depending on number of features that you have got, you would mention it. In our example earlier, so what we did, we have mentioned the input shape as 2. The reason, because we had two features. Since our input X had got two columns, I had mentioned as 2. So it is one per input feature. Coming to the number of hidden layers, I can have multiple hidden layers and there is no magic number for it. It is something that is unique for each and every data. Then we have got the number of neurons per hidden layer. It depends on the problem. So typically it is 10 to 100. And the output neurons over here, it is nothing but how many number of neurons that we want to have in the output layer. It's 1. Okay, in case of binary classification, it is 1 neuron. And in case of hidden activation function, it is ReLU. Okay, it's ReLU activation function. So typically it's ReLU activation function. And then in the output layer, we'll be having the activation function of sigmoid. Coming to the loss function, you will be using the binary cross entropy. Similarly, from the multi-class classification standpoint, so you will have one per input feature. That's everything is same. The only thing that you need to remember is the loss function and the output activation function. In case of multi-class classification, the output activation is softmax, loss function is categorical cross entropy. And the number of output neurons in the multi-class classification is one per label. Suppose if you are dealing with the multi-class classification where you have 10 classes, then in such scenarios, you need to have 10 neurons in the output layer. Okay, so that's the idea behind this, the number of output neurons right here. Coming to the regression, it's very important. Like three things are very important in case of regression. The number of output neurons is only one. Output activation is none. Loss function is mean squared error or mean absolute error. This is how you would construct the network. Now, these are all the important, I would say, important things that you need to remember when you are constructing the neural network. Now let's do a quick validation whether it's correct or not. And I'll also share you as how you can construct such neural network. So you have seen as how we can construct the neural network, right? Now, if you want to understand basics, so let me just take you to the TensorFlow library. So if I take you to the documentation page of TensorFlow, over here, we'll go to the tutorials of the TensorFlow. There's something called as a quick start for, let's use this one, okay? Yeah, we've got a data set that's called as basic classification, which is classifying the images of clothing. Now, this is a task of multi-class classification. So here, if you look into the code, everything is same as what you have learned so far. They are just loading the data set. Once they load the data set, some key things that you need to remember, each image is of the shape 28 by 28. Okay, that's one thing that you need to remember because based on these details, you would go ahead. Okay, you would go ahead and like based on that, you would go ahead and mention the number of features. So here they have done the exploration of the data. Let's come directly to the building of the model. See, the first thing that they have mentioned is a flattened layer. That means they are going to convert the multidimensional data into a single dimension. First, they will perform the flattening, and this is connected to a dense layer. Okay, they are having the ReLU as an activation function, which brings us to what we have learned earlier. See, in case of hidden layer, the hidden activation is ReLU, and that is what is being used right here. In the output layer, we make use of one per label. Now, in this example, we have got 10 output classes, and that's the reason in the final layer you have as 10. And the output activation function should be softmax. So in this example, they have not mentioned the softmax here. They have used it at a later point. But when you're constructing the neural network, you would generally mention 10 comma activation is equal to softmax. And then you will specify three things: optimizer, loss function, and the metrics, which is then followed by training the model. You'll just say model.fit, specify your training data. Now, once the fit is complete, see, they are actually updating the model with the softmax at a later point. So they're like at the end, once the softmax is completed, like they are going to generate the prediction. So the basic idea is, as you have seen in this today's session that you have learned so far, whenever we are working with this neural network, a neural network is made up of neurons which are connected in the format of a network. And in each neuron, you'll perform two things. One is linear summation followed by the activation. Okay, that's how you will be constructing the neural network. And when you want to construct the neural network, you have you have actually seen as how easy it is to work with this TensorFlow library. Okay, guys. So this was about the basics of TensorFlow library and the basics of deep learning. So with this, we come to the end of today's session on the deep learning fundamentals and the deep learning essentials. Now, if you're someone, folks, who is interested to getting started in deep learning and also apply this advanced deep learning on the generative AI, you can check out the courses from Manifold AI Learning. And there is one package that I would recommend. That's the Mastering the Generative AI in 2024. I highly recommend you to check out this package. This is a growing package. Currently, it has got 15 courses, and any new courses that gets added in future, you'll get those course access for free. There are two plans that are available, 2 year and the life plan. Depending on your requirement, you can choose the one and get started in your learning journey. And any new courses that gets launched, you'll get the access until the validity of your subscription, guys. And the best part is it has got all the amazing courses. Like, to give you an example, there's a recent certification by NVIDIA, which is an NVIDIA certified associated generative AI LLMs, the practice questions, Python for ML ops, LLM ops, that is working with large language models, generative AI, NLP bootcamp, Python for data science, then AWS machine learning certification, deep learning with TensorFlow, deep learning with PyTorch, calculus, statistics, linear algebra. So you'll have the access to these ultimate courses from the manifold AI learning. So with the upgrades and the updates for free. Okay. If you've got any question, please feel free to let me know. I'll be happy to answer any of the questions that you might have got. And I'll be uploading today's session code into the manifold AI learning workshops, which you have seen already. I'll be uploading the course, and even the team will be uploading the recordings over here under this manifold AI learning workshops. So thank you so much again, everyone, for taking your time and joining in with me today. So it was amazing to interact with each and every one of you. I hope this session was fruitful for you to help you understand this neural network. So this is one part where I had actually personally struggled, especially in understanding the intuition. I hope this session helped you to build the intuition around it. So thank you again, and I hope to see you next time, guys. So team, thank you again, everyone. So I'll be ending the session. I hope to see you next time. So if you have got any question, please feel free to let me know. Okay, thank you, everyone. Bye.